Davide Valenti, and it is my pleasure to present the work I carried out at the University of Bologna under the supervision of Professor Giuseppe Notarstefano for my master's thesis. This thesis addresses the challenge of enabling autonomous vehicles to navigate safely in dynamic environments populated by other vehicles, pedestrians, and also static obstacles. To this end, we introduce a transverse reparameterization of the vehicle's kinematics, which transforms the trajectory generation task into a non-convex optimization problem. Once an optimal trajectory is computed, it is robustly tracked using a maneuver regulation controller, the advantages of which I will detail shortly. By reformulating the dynamics in spatial coordinates, we express the vehicle's position and orientation as error states relative to a predefined reference path, the so-called centerline gamma. We further promote the time variable to a state within the optimal control problem, embedding it directly into both the cost function and the constraints. This inclusion allows us to account explicitly for the time evolution of moving obstacles when enforcing collision avoidance requirements. We validate the proposed methodology through two levels of simulation. First, in a simplified Python environment, the vehicle is tasked to follow a chicane-shaped center line at constant speed, while laterally overtaking a slower moving obstacle. Then, in real time, a professional simulator with high-fidelity vehicle dynamics, we reproduce the same scenario to demonstrate the approach's practical viability. The core of our control strategy departs from conventional point-wise error tracking. Instead of minimizing the instantaneous difference between the vehicle's position and the time-indexed reference point, we perform a projection onto the trajectory. At each control step, we identify the nearest spatial coordinate on the planned path and minimize deviation with respect to that point. This yields a combined feed-forward feedback law implemented in the time domain, yet evaluated at the closest spatial reference. The result is improved tracking performance, particularly in the presence of disturbances or tight maneuvers. Finally, I would like to show you a slightly different scenario: 3 static obstacles and an initial state perturbation. Even under this condition, the vehicle swiftly replans and avoids collisions, maintaining proximity to the center line with negligible deviation.